So this right here today is day 4. Day 4 is with exponentials and logarithms. Now, I'll tell you right now, a lot of people from last class struggled because they didn't have solid foundations from Algebra 2 or whatnot, or it's just been a while and they forgot. If you have any questions, please, just like always, make sure that you are asking me as we go through. So what I want to do now is I want to put this e to the x function into the calculator. And follow me. You can also look at the video at a later time. From this screen, I'll press 1 for new document, no for unsaved changes, and press 1 for add a calculator page. Then I'll press Control Doc and add a graphing page. And the reason why I want to add pages and not use Sketchpad, and Sketchpad, in case you don't know, is right here, or Scratchpad, the A and the B. The reason why I don't want to teach you how to use that is because you don't have the ability that you can have if you are using documents later, of which I will be able to show you. These document pages talk to each other, okay? So let's press 4 for the current page, and let's go back to our graphing calculator. I'm going to put e to the x. And now there's my function, okay? Now if I asked you guys, what is the value when x is 0, what would you say? 1. And if I asked you, what is the value when x is 1, what would you say? Not 2. It's close. But my point is, how do you find that value? Well, you can look at the table, right? And if you look at the table in this calculator, you do it by pressing Menu, 7, Split Screen. Now this will only give you x is 1, 2, 3, 4, all the integers. It doesn't give you like 1.234. So if I wanted to give me decimal numbers, this is what I'm going to do. Menu, Table, Edit Table Settings. And I want the independent variable set to ask. Some of you have learned how to do this with the TI-84s. This is how you get to it and use it with the TI-Inspires. Okay? So I'll do that again. Here we go. Menu, Table, 5 for Edit Table Settings. And this third one down that says independent variable, which is your x value, your input, you're going to do it to ask. So it doesn't automatically fill it out. See, normally it would automatically fill it out here. But it's not going to automatically fill it out. It wants you to prompt or to input what value you're talking about. For instance, if I put 0, it would equal 1. If I put 1, it equals 2.71828, so on and so forth. So a fast way to get a table is to do Control T. Look at that, it'll go away. If I do Control T for table, you know how to spell table, it'll come back. Okay? Now when it comes back, it goes back to the default of it's just automatically inputted in. But if I press Menu 2, 5 again, I can change this to independent variable set to ask. And now, if I wanted to know what is e raised to the power of 1.234, it would be that. Okay, there's calculator usage for you. Now, Control T to get rid of the table. What if I didn't want to use the table? And I'll tell you right now, I don't like using tables. I mean, of course, we have to know how to use them. But I don't prefer them. I prefer using my home page to find out what those values will equal. Now remember, I told you these pages, they talk to each other. So on this graph, F1, if I move up, F1 is stored, and you see it bolded, okay? It's nice and bold right here. F1 is bolded, otherwise stored as e to the x. So on the home screen, if I want to use f of 1, I would just press F1 of 0, and I get 1. Okay? F1 of 1 is E. Otherwise, look at this. Press Control Enter, and it gives you the decimal equivalent. 2.71828182846, and it goes on and on and on. Okay? Any questions so far with the calculator? Yeah?
So it's automatically stored? You don't have to do anything?
Correct.
Okay.
So there's the thing, is that before, when I taught you how to do stuff, I said e to the x, and then you would Control store it. Remember that? And you could store it like g of x, f of x, whatever you wanted. So if I did g of 0, it will be 1. If I did g of 1, it would be the 2.71828, which is e. Okay? Any questions? Okay. So, just like Diego said, you don't necessarily have to store it this way. You can store it simply by using the graphing calculator. Automatically stores it. Alright, so now let's go back to our values here. So this has already been pre-filled for you. This is our first sheet that we're going to do, okay? And you can go ahead and start filling them in, and you can see what are these values doing. You see to the negative, it's very, very close to 0. Then here, at a very important point, at 0, 1 is right there. And then also at, when x is 1, the y value is 2.71828. Those are two important points. And then it goes on, so on and so forth. Now, domain, okay? The domain, I know we've done domain many times, not only this year but last year as well. Domain we scan with a vertical line. So if I were scanning this with a vertical line, and I went left to right, it would look like this. So scanning this graph, remember that metal detector analogy? What x values do you see existing? Where is it touching the graph? Everywhere. Everywhere, because you know that this is going to have arrows and this is going to have arrows. Okay? So the domain is all real numbers. Otherwise, negative infinity to positive infinity. Okay? The range is talking about all the y values. So we're going to scan the y values, otherwise the y-axis. Do I exist down here, yes or no? No. I don't exist until what? After 0. Nicely done. After 0. So that's why you see that it is not touching 0. Okay? And then asymptote. It's not visibly shown there, but this says that the asymptote is at y is equal to 0. Now we've done asymptotes as dashed lines, and I'm going to do this as a dashed blue line right here. This is that y is equal to 0. Okay, remember that's a graph, that's a line that the graph will approach but never hit. Okay, now watch the highlights. As x approaches infinity, f of x approaches infinity. You with me? It's saying as it goes to the right, the graph will go up forever. Okay? The other part is as x goes to negative infinity, otherwise as it goes to the left, the graph will approach what? 0. Okay? Very important attributes about this. And E. What did we say E was? Didn't we use E last class? It's not times 10. Good guess though.
It's like pi.
E is a constant. E is a constant like pi. Okay? Now remember this equation from last time? A naught 1 plus or minus r over n to the nt. Remember this? This is what we saw, compound interest rate last time. And this, if it was adding, it was increasing. If it was subtracting, it was decreasing, and so on and so forth. We did it with the college loan. We did it with all those examples. Well, E, if it's here as the base, it looks like your initial times E to the RT. We ended class with something that looked like this. Okay, and I even said sometimes A sub 0 could just be written as P, like the PERT equation. P is your principal, the money you start off with. R is the rate. T is time in years. And E represents the natural rate of growth. Okay? So in natural phenomena, just in nature, things will naturally grow at a constant rate associated with E in a lot of respect, in a lot of ways. Okay? Now, do we have time to actually look at stuff today over that? No, but we will, okay? But that's the natural rate of growth. So E is this 2.71828182846 and so on and so forth. let's look at something that looks a little bit like e to the x. Your next graph that we're going to analyze is natural log of x, because we're doing exponential and logarithmic functions. Okay, so here we go, natural log of x. This is what natural log of x is. Notice the changes. You do have an asymptote, but this time it's a vertical asymptote at x is equal to 0. Okay? The domain on this guy was all real numbers. What's all real numbers on this one? The range. And vice versa. The range over here was everything above 0, otherwise the x-axis. Here, everything is above 0, which is the y-axis. So, e to the x's domain is natural log's range. And vice versa. You know what I mean? Now, let's look at this. As we approach infinity, the graph will still approach infinity. As you go to the right, the graph will increase. As you go to the left, so as you go to 0, not to the left, sorry, as you approach 0, the graph approaches what? Negative infinity. It goes down. If I were to draw these two graphs on the same graph, e to the x would look like this. What relationship do you see already? It reflects across what?
The y.
Y equals x. So this isn't like a vertical reflection across the x-axis. It's not like a horizontal across the y-axis. It's a diagonal reflection across the x-axis. And if this occurs, guys, then what are those two functions? What do they have in relation to one another? What are they? Inverses, yes. Inverses. So these are inverses. These are inverses of each other. Now, what are the easiest inverses that you know of that you can tell me right now? I want to hear what you're thinking and what you're going to say. What two different parent functions do you know that are inverses of each other besides these two?
Square and square root.
Perfect. X squared and square root of x. And the reason that is because if I were to take the square root of something that is squared, what happens?
2 and square root cancel.
It cancels, right? There's a cancellation that happens. Or if I square a square root, there's a cancellation. Guys, what do these cancellations cancel to? A form of what? 1. Nicely done. A form of 1 with these cancellations. That's the same thing with this. And it looks like this whenever they cancel. If I have a natural log of e to the x, these cancel to a form of 1. And guess what comes down? Just the x. Okay? How about if I had a natural log of x? Well, this one's a little bit different. Let's pay close attention to this. To get rid of this natural log, I'm going to apply a base of e. Okay? These cancel and x comes down, and you're just left with x. Okay? That's how the cancellation occurs. All right. Let's go back to this. What base? What's our base? I want to know if you know what a base is. What base do we use in regular math that you've learned since kindergarten? What base? Base. Huh? 10. We use base 10. We say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you know how we do it? We say 20, 30, 40, because it's the fourth group of 10. It's the fifth group of 10. You understand? So, bases, you could have different bases. For instance, if I had 4 in base 10, it'd be 4. You with me? But if I said 4 in base 2, what would it be in base 10? Well, this is how you do it. Look, listen, a lot of us don't know bases real quick. You don't need to know for the test. I just want you to understand where these bases come from, because a lot of people don't understand what bases even mean. So count to 2. 1, 2, that's one of them. And then 3, 4. So this is what we know of 2. Okay? So, what I want to show you with these bases is this. You can also have a base of e. Instead of 2, instead of 5, instead of 8, you can have a base that's 2.7, 1828, 1828, 46, blah, 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 whatever. The constant that he was talking about. So if you see natural log, sometimes you can look at it as log base e. So log, just log, has a base of what? In other words, if I told you, let's see what you remember from Algebra 2, what number is understood to be here as a base? 10. And it's called the common log. Okay? So it's supposed to be there without you even looking at it. When you take the square root of x, what number is supposed to be here that we don't write? 2. Good. Just want to make sure all these subtleties you have. So, natural log has a base of e, because the natural log of x could be written like log base e of x. Okay? Alright, so let's go back over here. So guys, what would natural log of e be? What would it equal? What would it equal? I'll just remember. Without the calculator, check this out. The natural log of e is equal to something. Okay? Let's figure this out. What did I say you could write this natural log as? Log base e. And now we still have this parentheses e, and we don't know what it equals. Here we go. The best way, you're going to use this a lot for the rest until winter break. The best way to solve a logarithmic function is to change it into an exponential. So if you have some kind of log, change it to an exponential. The best way to solve an exponential is to change it to a log. I know it's weird, but it helps a lot, okay? Let's look at this. How do you change a logarithmic function to an exponential? Is like we call it the reverse heart method. Okay? You're always going to start at the base and counterclockwise let's draw a heart. Sideways heart. So the way I'm saying this is e to the power of x is equal to whatever is right there. So what would x have to be? X would be 1. X being 1 would make this true. So if x is 1, that means my answer is 1. So you're going to put that right here. What's another way that we could have known that some of you are like, duh. What's another way that we could have known that this was 1? E and natural log are what of each other? Inverses, and they cancel to 1. Okay? So, this one's a little bit weird. What would that equal? It would equal 1 as well. Because a base with the number 10 will cancel out. If you don't see it, I definitely want you to be looking at log of 10 and 10. What would it equal? Let's put x. And 10 to the power of 10, or 10 to the power of x is equal to 10. The only way that'll work is if x was 1. That's why it's 1 right here. Questions? Okay. So let's move on. Domain. Who can tell me an easy way to remember the domain of a log function. Remember, log functions, they look like this. Okay? You have two types of logs. You have a natural log, and you have just a regular log. Let's see if it's still pulled up. Yep. Here we go. Natural log is the red graph. Log with base 10 is the blue graph. Notice the things that they have in common. They are both going through the point 1, 0. Okay? Tell me, what are the domains for both of these graphs? 0 to infinity, not including 0, right? So you could say x is greater than 0 or 0 to infinity. These are the domains. Okay? Guys, can you tell me what this equals? I root 5, right? But this is imaginary. This isn't a real number. So if I asked you for real answers, you would say it doesn't exist. You say undefined, right? That's why on a square root function, we don't draw anything to the left. We draw it to the right because it's only positive and zeros. Is 0 allowed to be a number on natural log or log? No, it can only be positive. So when I'm looking at domains, these pieces right here can only be what? Positive. So let's find the domain. We're going to set that piece greater than 0. This is what you have to memorize and remember what to do. Okay? It has to be bigger than 0 because we know it does not exist at 0 because it's a vertical asymptote, but we know it also doesn't exist at the negative numbers. Okay? And then solve for x. So 12, x is going to be less than 12. Are you with me? Okay. So this domain, we're going to say x squared minus 25 is going to be greater than 0 because for the same reasons, you have to have positive in this thing right here. And I'm gonna tell you right now what it's called, and I'm gonna ask you later, see if you remember for bonus points. This is called, here we go, let me show you. You have log base something of something is equal to something. This is ground level. This is like a basement. It's like a sub below written. This is notation wise. What do we call numbers that are right? What do we call numbers that are right here? Base. What do we call numbers that are right here? I don't expect you to know, but I'll tell you right now. That's what I want you to remember. It's called the argument. Okay? I know that's a weird thing to call that parenthetic piece, but it's called the argument. Okay? And over here is usually that power that we're going to raise it to when you rewrite it in exponential form. Okay? Alright. So, that's why I saw some of you looking at me a little weird. X squared minus 25 is greater than 0. That's what we're going to set for our domain. And when I solve it, I'll have x squared is greater than 25. Who can tell me the next step? Square root. What am I missing? Look what I just did. What am I missing? Plus and minus. And the minus, when I divide or multiply with a negative, when dealing with these things, what do we do to those things? We flip them. So I have two answers here. I have x is greater than 5. That's the positive one. Let me highlight that for you. The positive answer is this one. But the negative answer, oops, it's not going to be x is greater than 5. It's going to be what? X is less than negative 5. Okay, those are my two answers. The gray is over here. Not only did I put the negative on the 5, but I also flipped the inequality sign. Any questions? So, I want you to write it like this. So you have negative 5, you have 5, open, open. You're going to have it where it's less than negative 5 and greater than 5. And the answer, the way I want you to write it, is negative infinity to negative 5 union 5 to infinity. this is how you write the domain. Okay. Let us now move on, and we're going to evaluate these without a calculator. Without a calculator. Now, I'll give you, actually, we'll just start with the examples. I'll give you the first example, and then I'll call on you, so please be ready, okay? This is equal to something. I'm going to say x. Finish this sentence for me. The best way to solve this is to what? Change it to an exponent. Change it to an exponential function. How do we do that? Anyone? Reverse Hart method. Nicely done, yeah. So it'll be 2 to the power of x is equal to 16. Some of you can see what x should be to make that happen. If you do know it, say it out loud. What would x have to be to make 2 raised to that power become 16? 4. Yep. So if x is 4, then this whole thing equals 4. Okay, so you help me out with the next one. What do I do? So you're saying it's just 1, right?
Yeah.
And did you do this in your head? 6 to the power of x is equal to 6? Yep, and then x would equal 1 would make this true. Therefore, if x is 1, the answer is 1.
Will this be one if the base and the next number are the same?
Yes, it will always be 1 if these two numbers are the same. Nice observation, Gabe. Okay, let's do this next one. Gabe, help me out with this one. What do I do? The heart. So what number is here? 10. 10. Common base, 10. And 10 to the power of x is equal to 10,000. Gabe, what is x?
10.
Not 10.
100.
Not 100.
1,000.
Not 1,000. It's not 3. 4. 10 to the power of 4 is equal to 10,000. If you don't know the shortcut, guys, do 10 times 10 is 100. 10 times 10 times 10 is going to be 1,000. Right? And then 4 of them will be 10,000. The shortcut is this. However many zeros you see is what that power would be. Okay? Alright. So this answer is 4. Let's go with this one. This one's a little bit different. Who wants to take a shot at this one? Megan, go for it. What do you think we do? Yes, we're going to do the heart method. We're going to set it equal to x. And what do I write with the heart method?
7 to the power of x equals 1/49.
Perfect. Now, some of you can see it right now, what this is. Some of you maybe not so much. Hopefully what you see is that there exists a relationship between those two numbers. Okay, what number pops into your head? Not 7, 2. Because 7 squared becomes 49. Okay? So 7 to the x, remember this that we can do as far as with negative powers? Do you see that? This 49 was down here with the positive 1 as a power. And I decided to move it up into the numerator by changing the power to negatives. Because now, guess what I'm going to do with 49? I want the base to be the same number. That means I'm going to change 49 is now 7 squared. Do you see what I'm talking about? They have the same base. And when I started the unit in the notes and I said, we count in base 10, and I showed you base 2, and a bunch of you are like, whoa, that was weird. You know what I mean? We want the bases to be the same, because then it's easy, because you're talking the same language, if you will. What do I do with powers raised to a power? Multiply. So what I'm really looking at is 7x is equal to 7 to the negative 2. And once these are the same, guys, once these bases are the same, we no longer have to look at them. The only thing that's important is setting the powers equal to each other. So, my answer is what? -2. Okay? Alright, here we go. This is equal to x. Let me get a clear one for this one. This one's equal to x. And if I rewrote it, I have 6 to the x is equal to 1. And some of you are kind of cringing right now because it's like, what is this?
6 to the power 0.
6 to the power of 0. Nicely done. Anything except 0 or infinity raised to the power of 0 will always equal 1. So infinity to 0 is not 1, and 0 to the 0 is not 1. Anything else is equal to 1. Okay? So this answer is going to be 0. Okay? Now this one has a common base of what? 10. So we have 10 to the power of x is equal to 0.1. Any volunteers? What should I do from here? Megan? Any suggestions? CJ? Okay, this is a good mistake, and I'm going to give him participation points for this. What is going on between 10 and x right now? Is multiplication going on between 10 and x? No. So you're not going to try to divide by 10. That's a big common mistake, okay? This is an exponent. This is a power. This is a base. Okay?
Could you make it a fraction?
You could make it a fraction. So let's make 0.1 into what?
1 over 10.
1 over 10. 1/10.
Yeah.
Okay? And then what, Diego?
So -1.
Yep. Then I'm going to change this 10 to the over here to the -1. The left side stay the same. And now x is what? -1. Nicely done. So -1 is my answer right here. Okay? Alright, let me show you something. Check this out. If I'm looking at log base 10 of 5, and I wanted you to tell me what this was. Okay? And I put it is equal to x. You can do the reverse Hart method, and some of you already see it. You see 10 to the power of x is equal to 5. That's where you would start, right? But then, it's hard to go from there, isn't it? It's like, what's going on right here? I don't know what this power would be to get me a 5. It's not 2, because that'd be 100. It's not 1/2, because that'd be the square root of 10. See what I'm going with all this? So, what you can do, another way to get rid of this is to cancel that log. How do I cancel log base 10?
Place another log on the second.
No, not another log on the other side. Nice try though. Not a natural log. I'm going to create a base of 10. Watch. My goal is to cancel this base out. How else to cancel? Than with the base itself. Okay? So that the 5 would end up coming downstairs, and you would have 10 to the x left over on the right side. I know that's a little weird, but if you don't see that, do reverse Hart method. A lot of people see reverse Hart method a lot easier than this cancellation of bases. Okay? Alright, let's move on. Now we're going to do it with the calculator. This, of course, is just practice. Please follow me with the calculator. We have log base 4, right here, control log, otherwise control 10x is the base. And we're going to put 4 for the base and 0.125. So here we go. 4, kick over to the right, and we'll do 0.125. We press Control Enter, and I don't, Control 6, let me get rid of that. We get negative 1.5. So negative 1.5 is the answer there. You with me? Alright. For bonus points, if I did this by hand without the calculator, what would be the approach? What do I do? Set it equal to x, and I have 4 to the power of x is equal to 0.125, right? Now what? What do I do? If you're doing it with the calculator with without a calculator, doing it by hand. You do a fraction, right? What's 0.125? Well, it's 125 over what? 1,000. Nicely done, guys. Keep going. How do I reduce this? I divided by 10. Let's reduce the right side. Let's reduce it by 25. How many 25s do you see on the top? 5. How many 25s, and this is number sense, I'm helping you build your number sense right now. How many 25s do you see on the bottom? 40. I should have divided by 125 because it would have reduced to what? 1/8. This is good stuff right now. Okay, now what should I do to get my answer? Change the exponent, right? I'm going to change this to a 4 to the x, 8 to the negative 1. Keep going with me. Now what? Parentheses. I'm going to make 8 into what? No, not 4 squared. That's 16. 2 cubed. Do you see that? What am I going to do with 4? 2 squared. You see what I'm doing, guys? So that I get, and nicely done by the way, 2x is equal to what? Negative 3. So negative 3/2 is negative 1.5. Ultimately, that's where I want you to get. Okay? Because then this unit is really easy. It really is. It's a lot of manipulation of what you see to cancel. And the only way to get it is through experience and practice. Okay? Let's do this one just with a calculator. Okay, so we'll say log base 1.8 and 4.89. Because some of these problems are going to be real-world problems that you do have to use the calculator. So we just want practice and making sure that you're good to go. And we're going to round to how many decimals if I don't tell you? 3. So 2.700. Okay? Alright. Evaluating with the definition of a log. Alright, here we go. What kind of function is this? Exponential. Okay? Exponential. The best way to solve an exponential, McKaylee, is to do what? Turn it into a log. So, what should I do, McKaylee? How do I write it? Log base what? 10 of what? Yep, is equal to? Yes, okay. And if you don't know and you're kind of guessing, it's always good to just check what you did and make sure it would go back to 10 to the x is equal to 25. Okay? And now that you have it, now I can put this into my calculator as far as log with the base 10 of 25. And I can quickly get 1.398. And I put squigglies because it's approximately 1.398. It's not equal because you have remainders and more numbers still going. Eric, do me a favor. Can you please read this for me? Try not to skip any details. 20 what? Say again? 20 to the e. Keep going. Okay. 20 to the ex equals 90. What he said was that. Who else wants to try it? Go for it. 20 times e to the x is equal to 90. So that's very, very important right there. Because if I told you to solve for x right now, what would you do first to both sides? Divide by 20. Now what would I want you to do to get x all by itself? Not square root. Natural log, right? See, how do you cancel this out? By taking the natural log of both sides. What you do to one side, you have to do to the other. These cancel, the x comes down, and you're just left with this. And on the test, you'll have some of you, even on your final exam, you'll have some to where you're not going to have the calculator. You're going to have a calculator and non-calculator portion. This could be a multiple choice that you got to learn how to solve for it without a calculator and what it would equal. This could be like whatever letter the answer is.
Can you reduce 90 over 10?
You can just divide by 2 and say 45 over 10, and then divide by 5, you get 9 over 2. Yeah, duh, divided by 10 on both of them. Alright, so let's come over here. Let's look at natural log of 2x is equal to 5.5. What do you see? If I told you to solve for x. Just say it out loud. Don't be shy. How do I get x all by itself? What should I do? Okay, so this is a good mistake. She will get bonus points too. I'm not multiplying by natural log. It doesn't say natural log times 2x. It says natural log of 2x. And I know the word of in math 90% of the time means multiplying. But guys, if I told you f of x is equal to x squared, are you multiplying right there? No. Just like you're not multiplying right there. Okay? But I know we have to get rid of, like Megan saying that you're multiplying, she's trying to get rid of natural log. Because she was like, let's divide by natural log. But that's not how we get rid of natural log. How do we get rid of natural log? By taking a base of e to both sides. That's ground level right there, guys. Okay? Because think of this right now as in the attic, and these are like on the first floor, if you will. Okay? That's just the notation. I want you to be clear of where the location is. Those cancel, and the 2 comes downstairs, and it's just equal to that. Ask me questions if you have them. Now what do we do to both sides? Divide by 2. And again, this could be an answer to a multiple choice question that you got to know how to manipulate stuff. And I don't mean this one specifically, so please don't memorize that. I don't mean that at all. I'm just saying, understand that you won't have the calculator for some of these. Okay?
So you divided by 2 on both sides, right?
Yep.
Or no, you divided by e on both sides?
No, I divided it by 2 on both sides. So divided by 2, divided by 2.
When you wrote e below it, were you not dividing?
I'm not. So here we go. Look, check this out. Help me get rid of this square root. What do you do to get rid of the square root? Okay, you're squaring something. Are you multiplying or are you dividing? Neither. You're applying a square root. Or sorry, a square. You with me? There's no multiplication going on. It's applying so it'll cancel. Alright, so let's do this last one. CJ, what do I do? And what's right here?
10.
So 10 to the is 0.5x, right? Now what? Keep going, CJ. Bless you.
Would you simplify 10 to the third?
Which is
100.
no.
1000.
Yep. 3. So 3 zeros. And that's the the shortcut when you're doing powers with 10? And then the last thing is what? Divide by 0.5. So look, if I divide by 0.5, you see what I did and you see what I wrote? If I divide by 0.5, it's the same as what? Multiplying by keep, change, flip. So 2000 is x. Okay? You guys are doing well as far as the number sense building that's going on, especially today. Alright, we have 3 properties. I think we might have time to present after all, okay? And that's up to you if you want. If not, you can work on homework because I already have the homework assigned. And it's due next Friday, but I want you guys to start immediately because you're going to have questions, okay? You are going to have questions and I need you to come in for equal time and whatnot. Alright, product property is this. If I have the log of x times y, it's the same as the log of x plus the log of y. The big thing here that I want you to learn is that multiplication is the same as if I were to break it up into 2 logs that are added. Now, do you think this works with natural logs as well? Do you think those would actually work as well?
Yes.
It does. Log or natural log, they're the same, okay? Because remember, the domains, like I showed you back on this thing here, the domains are the same. Okay? Alright, so let's come back. The quotient is log of x divided by, because that's what quotient means, quotient is dividing, is equal to log of x, what? What do you think? Minus. If people make a mistake, you help me out for bonus points. What would they write next? Huh? I can't hear you. What would they write? They would just, not log of y. If they made a mistake, they would just write y. Okay? Make sure that you understand 1 log becomes 2 logs if you're going this direction. Okay? And yes, of course, the division is subtraction. And last but not least, if you have a log of, oops, that's not log, that's logs. Log of x, this is equal to log of x raised to the a power. What happened? All you did was you moved this power from a coefficient to the power of the thing in parentheses, which is called the what? Argument. Nicely done. Alright, argument. So the coefficient in front, this is like 2 times natural log of x, will become log of x squared. It's the power of the argument. And you can move it back and forth. Yes?
Like how we said in the product where you use natural log, does that work for a quotient too?
All of these work for natural logs. Okay? Alright. Here we go. And you can volunteer. Just raise your hand and let me know. Say again?
We don't have that.
Oh, you're going to write it in. Sorry. This is like the foldable part to it, okay? So, my bad on that. So just whenever you open it up so that you can see it. And yes, this is a foldable. So, guys, look. Just like Gabe's doing. You're going to glue it like this. And then you're just going to cut each one so that you have 3 doors opening. And you can see an example problem right behind it, okay? Alright, we're going to use the property of product rule, okay? Again, we know that this is log of x times y is log of x plus log of y. Anyone want to volunteer? First of all, I skipped over something that's very important. These properties only work if blank. What's the blank?
Both of them.
Isn't there a rule with the parentheses?
You're close. parentheses, but you're close with it. You can do this. You can do this from this if and only if they have the same base. If they have the same base, same language per se, you can do it. Okay? Do these have the same base? Yes. What's the base? No. What's the base? Oh, sorry. Right here on this one. What's the base? E. Natural log is the same as if you were to write log base E of x plus log base E of x plus 1. Those mean the same thing, okay? Alright, so I'm going to bring two together into one huge natural log function. And what am I going to do with these two, what are those called? Arguments. I'm going to multiply them. I'm going to multiply them because this addition tells me that I want to multiply them. What is wrong with the way I wrote it? Parentheses. I need parentheses here because this is going to distribute to most likely of what you will see written like that. Nicely done, guys. Okay? Judd, can I combine all of these three? Yes or no?
Let's say yes.
Why can't I? You're right, but why can't I? Someone help him out. Why can't I? The same base. What's the base on these? 10. So you don't have to write them, but these all have 10 as their base. So I can put them all together as one huge log. And again, I don't have to write the base 10. It's just automatically there, just like you don't have to write 2 for square roots. I mean, if you write it, I'm not going to count it wrong. But what would I do with all these numbers anyway? I would multiply. Because addition multiplies and subtraction divides. Okay? A good way to remember that is subtraction divides. Okay? Addition. Oh, it's not going to let me. Oh, man. Addition. Be good to me, board. Alright. Is multiplying. Okay? Anyway, so let's look at this. What's 4 times 5 times 5 going to equal anyway? 100. So the answer is, no, not 45. Log of 100. Is that my final answer, yes or no? No, log of 100 is not my final answer. We want to simplify as much as possible. Who can tell me what this can simplify further to? 2. Nicely done, because this is equal to x. 10 to the power of x is 100. So that whole thing is 2. Good? Alright, we're almost done, guys. We're almost done. 2 more examples for quotient and 2 more for power rule, and we are done. Let's go with quotient first. What do I write? Katie? No, Kaylee. What do I write, Katie? Kate, I'll let you do the next one. So I'm going to write 1 log and do what? And then I'm going to divide them. So what do I write up top? And then on the bottom? Guys, does it matter? Does it matter if I put x minus 2 on the top or bottom? Yes, it does matter. Because division has what? Order matters. 1 divided by 3 is not the same as 3 divided by 1. Be careful with that, okay? Multiplication it doesn't, but division it does. Is this final? Simplified? It is. See, the other one, we could simplify more because it was just numbers. Okay? When you have variables, for the most part, 9 out of 10 times, it's pretty much simplified. Cool? Alright. Okay, let's do this last one. Or this one over here. What could I do? Yep. But why? How do do you know I can combine them together, Kate?
Because they have the same.
The same base, right?
Yes.
Now, do you have to write it, Kate?
No.
You do. You do. 10? Hey, 10 is the only one that you don't have to write.
I was leaning on no, but
No, you do.
Didn't even realize
I was
It's all
somewhere
good.
like half and half. Like it makes sense if you do, but
Yeah, here's the thing. You do on this one. The 10 you don't because it's understood, but anything other than 10, I want you to, okay?
and wouldn't it be just log 5 base 25 just to simplify?
Log base 5 of 25, yes. What does it not have right now? It doesn't have variables right now, right? So could you reduce it even further?
Yes.
Yes, because this all equals something, and 5 to the something is 25. What would that something have to be? 2.
Great. So I assume we're not getting the same problems that I get because they don't have variables and they're easy to simplify them.
I mean, you're going to get both. Okay?
That's
Let's go to power property. Kaylee, let's start with you. What should I do?
you put the coefficient
Yep.
over the x in the power.
Perfect. And then I'm going to do what with the 2?
You move the 2 into the power, and then you end up multiplying them, don't you?
Oh, further, yeah. Let's do one step at a time, though, okay? And then 4 is going to be
It's going to be the same as the others.
power. Okay, so I'll write natural log of x squared plus natural log of y, oh, not squared, my bad, cubed. And then y, how dare me, minus natural log of z to the 4th. And now, can I multiply, ooh, that's a ugly number. Can I multiply these two together, yes or no? Yes. Why? Because they're the same base. What's the base again? E. Yes. So it's going to be natural log of x cubed times y squared. You with me? But what else are we going to do with this argument? We're going to divide it. So over here we're going to put divided by that. And I feel a tricky bonus coming with something more difficult from this basis. Dealing with this kind of problem, so just make sure that you're good to go with this kind of stuff. Can I reduce anymore? No. Okay. Let's come over here. What do I have? Let's simplify. Use properties and then simplify. What is this simplified to? 6. Some of you could see it just like that. If you can't see it, rewrite it to that. We did what McKaylee did, but backwards. We brought the power down to the coefficient. And you should know by now, what do those equal? 1. So this is just 6. Otherwise, cancel, bring down. Okay? What will this be? 10. Nice. Because 2 gets raised to the power, and that will become 10. So my answer is -4. Any questions before I stop the video? Because you guys did awesome. Okay, that's it.